Question 6. We've got two functions here, f of x and g of x. G of x is a log function and f of x is an exponential function, and the first part asks us to find the first derivative of both of them. And here's f of x. So to find the differential of an exponential function will be the same thing, which is e to the 4x squared minus 1, but we have to differentiate the power as well, and the differential of this expression is 8x. Now we're differentiating the log function, so the differential of 8 ln x will be 8 multiply the differential of ln x, which is 1 over x. So this is equal to 8 over x, and that's the answer to part 2. So now in part B we're told that the differentials are equal to each other at x is equal to alpha, and we've got to prove that alpha satisfies this equation. So all we've got to do is equate the two functions and solve for x. So there are the two functions equated, and straight away we can cancel an 8. So dividing both sides by this x, I get that e to the 4x squared minus 1 is equal to x to the minus 2. So if I now take logs, and it will be natural logs, and the log of e raised to this power is simply the power itself. So this is 4x squared minus 1, and that is equal to the log of this. So for the moment I'm just going to write ln x to the minus 2. Now by one of the log laws I can bring that power down and use it as a multiplying factor. So at this point I look towards their answer, and they've put everything across to the left hand side and the right hand side will be 0. So all I've got to do is move my negative 2 ln x and push it across to the other side. And that's what they wanted. So in the last part of the question we've got an iterative formula, and this is a chance for the calculator to shine. We're given that x1 is equal to 0.6. And the iterative formula is designed to find an approximation for alpha, which effectively will be the root that this iterative formula is desperate to find. Alpha will be the result of pushing that equals button on the calculator so many times that the display won't change at least to 4 decimal places. So they first of all want us to find the value of x2. So if you substitute xn for 0.6, set that up in the calculator, you will get a value of x2 as equaling 0.710923, which to 4 decimal places is 0.7109. So if you've set this up in the usual way in your calculator now to just be able to push equals, 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 you'll find that the display settles on the root value alpha is equal to 0.6707, and that is also to 4dp, and that's the answer to part C. If I've gone a bit quickly on that, look up the use of a calculator on my website or on other questions as to how to organize the calculator such that these answers pop out relatively easily.